Alright guys, welcome back. We're on Chapter 9 still. We're going to be going over Chapter 9 Section 2 and Chapter 9 Section 3. First off, we're going to be starting with something you guys already know and love. We're going to be dealing with right triangles. And anytime we're dealing with right triangles and we know two of the three sides, we know right away that we need to start looking for some Pythagorean theorem. Also today as we go on, we're going to talk about some families, some right triangle families to help make life easier as you go on further and further in math when you're dealing with right triangles. After we get through that, we'll go through the converse of the Pythagorean theorem, and then we're going to end up working on, let's say, figuring out if, given certain lengths, if we can create a triangle or not. So that's going to be classifying triangles, whether they are a triangle or not, and then we'll be able to tell just by the lengths if they're right triangles, obtuse triangles, or acute triangles. So I'm going to go ahead and start us off here with some of the basics. First, our goal, use families of right triangles to solve for the missing lengths. Okay, first part here you guys know how to do. You guys should be aces at this. We see right away we're dealing with the Pythagorean theorem. Okay, we know the Pythagorean theorem deals with a right triangle. Then we have the two lengths and the long side, which is the hypotenuse. Key thing to remember here, the right angle points to the hypotenuse. As long as we got that down, we know our hypotenuse is always our C. As long as our hypotenuse is our C, we're always going to set this problem up right and make it very easy to solve. So we got a squared plus b squared equals c squared. Okay, remember we use this whenever we have a right angle and we're solving for one missing side. Okay, simple as that. You guys have been doing this forever now. No real concerns about this. Main thing, recognize the hypotenuse first as you're doing it. That's the only place we get tricked up. So if we see the first one here, we got to realize we're missing the C, the hypotenuse. So we set it up. 3 squared plus 4 squared equals c squared. First part's 9, 4 squared is 16 equals c squared. Add those together, it's 25 equals c squared. We square root both sides to get c by itself. And c equals 5, which we already knew. Okay? Next, we have another one. 513b. What we have to recognize is, here is our hypotenuse. So it is 5 squared plus b squared equals 13 squared. Remember, your hypotenuse is always your final number in this formula. So we got 25 plus b squared equals 169 minus the 25. B squared equals 144. Square root that. B equals 12. Right away we have our first two most often used right triangles. You will see these time and time again when you are going ahead and working with right triangles and the Pythagorean theorem. Okay? Now this can become a shortstop for you if you remember it. Now the key is to remember the order. The two smaller ones have to come first. So as we look up here as our most often used, our first one is right here. 3, 4, 5. Our second one happens to be right over here. We have 5, 12, 13. Our next one is going to be 7, 24, 25. Then we have 9, 40, 41. And 8, 15, 17. I'm going to put a little star by this one because this one's a little different than the rest. So as we're looking at these here, we notice right away that, or hopefully we notice right away, that if we take the second 2 and add them together, 4 and 5 is 9. Well, we take the first one and square it. 3 squared is 9. Our next one, and I forgot to put the 1 in front of the 13, 12 plus 13 is 25. So we look back at the first number, 5 squared is 25. 24 plus 25, 49. So 7 squared is 49. Here we have 40 and 41, that's 81. 9 squared is 81. And this one's a little bit of the oddball. You just sort of have to remember the 8, 15, 17. If you guys can memorize these, down the road it can be extremely, extremely helpful. Okay? Save you some time, save you some effort, and we'll be able to go from there. Jumping down here. Now we're going to learn some more about triangles. We're going to learn about their families. We're going to be able to find the missing side. And we're also going to be able to find the scale factor, okay, of the right triangle. So we have to go through this list to identify the third side by using triangle families. So they've given us 2. We got to find the third side. We can reduce the difficulty of the problem by multiplying or dividing the lengths of a triangle to find a common factor. So we want to try to find a common factor. And to do that, we multiply or divide. If we have a fraction problem, and we know these scare us, then we always change each given side into an improper fraction. Change it to an improper fraction with the same denominator. That's the bottom number. Get rid of decimals. So if we have decimals here, those scare us a little bit too. How do we get rid of decimals? By multiplying. Multiply all the numbers by either 10, 100, 1,000, etc. until the decimals are gone. Then we go ahead and determine the family. Well, here is our most common used families. Once again, 3, 4, 5, 5, 12, 13, 7, 24, 25, 9, 40, 41, and 8, 15, 17. Not a bad idea to write these out on some flashcards or something and just take a peek at them a couple times throughout the day because it will save you time. Now going on to solve the first one down here. We notice right away we have 35 and we have 21. What we have to do is figure out what number goes into both of those. Okay, what goes into both 35 and 21? Well, if we're looking at this, the number 7 goes into both of those. So what I do is divide this by 7 and divide this by 7. 35 divided by 7 equals 5. 21 divided by 7 equals 3. So I look here, I got 3 something, and then my hypotenuse, which is 5. So what I'm going to do first is look up here. 3 something hypotenuse. Right now I know my missing side is 4. So my family is 3, 4, 5. Now to find my missing side, this is a little trickier. Okay, I got to take the missing part here. Once I get the missing part, which is 4, I'm going to go ahead and multiply it by my scale factor, which is 7. This is how we found the scale factor. Now what I'm going to do next, I'm going to multiply these two together. So 4 times 7, and that should get me my side. My missing side is 28. Sorry if you heard an alarm. Got to tap that off there. Got a couple seconds here. We're going to try to do one more. Okay, so here we take a look. Uh-oh, we got the scary fraction. Okay, let's make it into an improper fraction. So how do we do that? We have 1 and 1/4. We take this, multiply it by this, then add the 1. 4 times 1 is 4. So this is 5 over 4. Okay? What to do here is multiply this by 4. Or excuse me, multiply this by 3. Sorry, 4. So what do we have? We have 4 over 12. Now the number hasn't changed because that would reduce down to 3. But now we can go ahead and look at it. Since the denominators are the same, let's look at the top numbers. We have 5, we have 12, we're missing the hypotenuse. So we go up here, 5, 12, hypotenuse is 13. 5, 12, 13. Our scale factor here, since we're dealing with a fraction, and it was a fourth, scale factor is 1/4. So what do? I take this number, okay, and I take this and I multiply them together. So we have 13 times 1/4, which is going to equal 13 over 4. One of the more difficult ones that we will practice more in class. Now we're going to go ahead, pause it, and start the next part of the video.